We now continue with the lecture on optimization problems. Here is the next example. A 1,000 square meter rectangular lot along a highway is to be fenced off such that one side of the fence is on the highway. The fencing on the highway costs 80 pesos per meter and the fencing on the other sides costs 20 pesos per meter. Determine the dimensions of the lot that will minimize the total cost of the fencing. Before we solve this problem, try to understand the problem first. Let's now solve this problem. So we draw a diagram for this problem. Ito yung lot. Tapos ito yung highway. Ito yung fencing along the highway. Tapos ito yung fencing along the other sides. We let x to be the length of the side facing the highway, y to be the length of the other side, and c to be the total cost of fencing the lot. Here we want to minimize c. Okay. We now express c in terms of x and y. Yung c yan yung total cost of fencing the lot. Tingnan natin yung side na along the highway. The fencing along the highway costs 80 pesos per meter. So since x meters ito, yung nasa along the highway, so the cost for this part is 80 times x. We now consider the other sides. So yung sa likod, the cost of fencing is 20 pesos per meter. And since yung nasa likod, x meters yung fencing, the cost will be 20 times x. Now, the cost of fencing for the sides, ito, at ito, 20 pesos per meter. But we have y meters for this side and y meters for this side. So, yung cost of fencing for these sides will be 20 times 2y. So, mag-a-add tayo dito ng 20x plus 20 times 2y. Okay? This is also equal to 100x plus 40y. We now express y in terms of x. Since the area of the lot is 1,000 square meters, yung area na yun ay equal din sa x times y. So, xy is 1,000. And y is 1,000 over x. Substituting this value of y to the y here, we get 100x plus 40 times 1,000 over x. Ito ngayon yung c as a function of x. This is also equal to 100x plus 40,000 times x raised to negative 1. 40 times 1,000 is 40,000. 1 over x is x raised to negative 1. We now get the constraint. Since yung x yan ay length, then x must be positive. So x must be in the interval, open interval 0 to infinity. We now get the derivative of the cost. So derivative ng 100x is 100. Tapos yung derivative ng 40,000 x raised to negative 1 is negative 40,000 x raised to negative 2. C prime is also equal to 100 minus 40,000 over x squared. Setting C prime to be equal to 0. Then 100 minus 40,000 over x squared equals 0. From this equation, 100 equals 40,000 over x squared, or x squared equals 40,000 over 100, or x squared equals 400. Solving for x, we get x equals plus or minus 20. Pero yung kailangan natin dito, x must be positive. So x is equal to positive 20. So the critical number of c on this interval is 20. We now get the second derivative of c. Yung derivative nito. This is equal to 80,000 x raised to negative 3. Since negative 40,000 times negative 2 is 80,000. This is also equal to 80,000 over x cubed. Pag sinubstitute natin dito yung x equals 20, then c double prime of 20 is equal to this one, which is equal to 10. That is positive. Okay? Since c prime is 0 and c double prime is positive when x equals 20, then by the second derivative test, c has a relative minimum at x equals 20. Hence, the total cost of the fencing is minimized when x equals 20. Tapos yung y dito is 1,000 over 20, which is 50. So the dimensions of the lot will be 20 meters and 50 meters. Yung 20 meters, yun yung side facing the highway, and 50 meters will be the other side. Okay? Next. A box is to be made from a rectangular piece of cardboard 48 cm long and 18 cm wide by cutting out identical squares from the four corners and turning up the sides. Find the volume of the largest rectangular box that can be formed. Before we solve this problem, try to understand the problem first. Let's now solve this problem. So we draw a diagram. Ito ngayon yung rectangular na cardboard. 48 cm yung length, 18 cm yung width. Tapos these squares will be cut out from the cardboard, and we let x to be the length of the side of the squares to be cut out. Let V be the volume of the box. Since we're finding the volume of the largest box, we maximize the volume, V. Next, we express V in terms of X. But before that, pakita muna natin kung paano na gawa yung box na yan. Ito yung rectangular piece of cardboard. Dito daw ika-cut yung mga squares. After the squares have been cut, ganito yung itsura ng cardboard. Ganito. The length of this side is x. The length of this portion is 18 minus 2x. Since the length of this and this is x, the length of this portion is 48 minus 2x. Since the length of this and this is equal to x. We now fold yung cardboard dito sa lines na to. Tapos iaangat natin yung side na to. Ito. Ito. At ito. To form this box. Open yung taas ng box. The box will have length 48 minus 2x, width 18 minus 2x, and height x. So the volume is length times width times height. So V of x equals 48 minus 2x times 18 minus 2x times x. The volume is also equal to 4x cubed minus 132x squared plus 864x. We now get the constraint for x. X is a length, so x must be positive. X must be greater than 0. Also, kailangan makapag-cut tayo ng dalawang squares along this side. Since x is the length of the side of the square, kailangan yung x hindi lumampas dun sa kalahati ng side na to. Since we should be able to cut two squares along this side. So x must be less than 18 over 2 or 9. So for the constraint, x must be greater than 0 and x must be less than 9 at the same time. So x must be in the open interval 0 to 9. Okay? We now get the derivative of v. So v prime x equals 12x squared minus 264x plus 864. This is also equal to 12 times x squared minus 22x plus 72. This is also equal to this. Setting v prime to 0. Then 12 times x minus 18 times x minus 4 equals 0. Solving for x, we get 18 or 4. Pero yung hinahanap natin dito dapat nandito sa interval na to between 0 and 9. So x must be equal to 4. So the critical number of v on the interval 0 to 9 is 4. Okay? We now get v double prime. This is equal to 24x minus 264. Pag sinubstitute natin ngayon yung 4 dun sa x dito sa v double prime, we get v double prime of 4 equals this one. 24 times 4 is 96. 96 minus 264 is negative 168. This is less than 0. Since v prime is 0 and v double prime is negative when x equals 4, then by the second derivative test, v has a relative maximum at x equals 4. So maximum ngayon yung volume ng box when x equals 4. And the maximum volume is given by v of 4. Substitute 4 here. So we get 48 minus 2 times 4 times 18 minus 2 times 4 times 4. 48 minus 2 times 4 is 40. 18 minus 2 times 4 is 10. And if we multiply this, we get 1,600. The unit is cubic centimeters. Ito ngayon yung largest possible volume. Okay?